Alright, let's try this again. So unfortunately my first calc is crashed, but it was right at the start, so I can just talk you through what I've done here. I'll just, let's just start the whole thing again. So we know A is proportional to B squared, right? And that means that essentially A and B squared are directly related, right? So it's not like, B squared plus something or anything like that. Okay, so A and B squared directly related, which therefore means that you could say that A is equal to some form of modifier times B squared, right? So all I'm doing is, instead of using this funky fish symbol here, I use equals K, which just means equals something times B squared. Now we know that A is 72 when B is equal to 4, so squared. So that means 72 is equal to 16K, right? Which means if I would divide both sides by 16, I would get the constant of variation K, right? Which would be, in this case, 4.5. I'll do it up on here just so you can see. 72 divided by 16, 4.5. Okay. That's good. Let's do the next one. So if y is directly proportional to, so that's that fish symbol I was talking about. So if y is directly proportional to 1 over x, right? Now this can be rewritten as y equals our constant of variation k over x, right? So if we know that x is equal to 50 when y is equal to 12, that means 12 equals something over 50, right? So that's this will help us find k, and then we can use that to find out when x equals 25 what our solution is. So to find k, we multiply both sides by 50. That'll give us 600 is equal to k. Okay, which means I can rewrite this equation at the top here as y equals 600 over x, alright? So I say when x equals 25, what's y? So it'll be 600 divided by 25, which is 24, I think. But I'll check it on the calculator here just to be safe. 600 divided by 25 is 24. Right, so we've got our first two questions done. Let's keep the party going. Okay, so we have a graph shown here that follows the variation statement y is directly proportionate to x. Right, so it means it's y equals kx. Alright, and we've got to figure out what the k is. Alright, so I'm just going to move this. Trying to make a slight adjustment on my screen. Hopefully that's not recording with a red line across. Okay, so y is equal to something times x, and we want to figure out the something. Now we can see there's clearly a linear line, which is usually what we're trying to achieve with variation, but in this case it's already linear, which is good. Which means that we know, because it's a direct variation, that it's y equals kx or mx. There's no like plus whatever. So we just got to find out what the gradient is, essentially, right? So we can do that by finding a value and substituting in. So you could do, say, what seems to be clean, 200 and 150. So you could say when y is 150 and x is 200, therefore k is 100 over 250, which is 0.75. I'll just make sure I've got that right. 200 over 1. Did I do that wrong way around? No, I did. 150 over 200. Yeah, 0.75. So I've got that, which is our answer here, so that's fine. If you didn't want to do it that way, you could just pick, you could do like rise over run or something like that, and have the, or do y2, y1 over x2, x1. Any of those would be fine, but this is probably the most efficient way to do it. This one, if r varies as the square of s, okay, so that means r, we have the fish, s squared, right, which means it's r equals kx squared. So we know that r equals 490 when s is equal to 7. Why did I do x? I meant s. Okay. What does it say? 490 equals k times s, so 7 squared is 49. Divide both sides by 49. We'll give you 10 equals k. Right. So 10 equals k. I think a lot of people stopped here and circled 10 as the answer. Just remember, you got to substitute this back in. So r equals 10 times s squared. If the r is 250, that means that the s, so divide both by 10, we get 24 equals s squared. Square root both sides, and you'll get s is equal to 5. Okay, so there's a little bit of working out to do there. That's our solution there. And it says correct to 2 places the number whose logarithm is. Okay, so if we're doing a logarithm, remember this is basically saying we're doing log 10 of something is equal to 2.22. This, remember, is the equivalent of 10 to the power of 2.22 equals something. Okay, so essentially to reverse that, we just got to do that. We just got to do 10 to the power of 10 to the power of, do I have to the power of on this calculator? To the power of 2.2, excuse me, 158.49. That's wrong. Why is that wrong? Oh, because I left off at 2. 10 to the power of 2.22 gives me 165.96. Rounding up. So be careful with the rounding because the next number is 8. So it rounds up. Alright. Alright, next one. The following graph shows a general rule y equals kxn plus c. Okay, so y equals kxn plus c. This is a tough one. All I will say is that you just got to substitute values in. Oh, I feel like, did we change this for the, maybe I'm doing an old version of the test. I feel like maybe we didn't scrap this question. That's all right. Anyway, I can just substitute this in to figure it out. So all I'm going to do is I'm going to take the points x squared being 12 and x squared being 12 and y being 64, which would give me 64 is equal to k times 12 plus c. Okay, so we've got that. To find k, I would have to do the solve for gradient. So I'll do that now. So y2 being 12 minus y1 being 8 over x being 64 and 0, which would give me, what does this give me? What about 4 there? 12 minus 8. What's the mod about 3? Alright, that gives me 8 over 64, which is the same as 1 on 8. Which means that has to be my answer, because k is 1 on 8. None of the other ones match up, but just in case, if we substitute that in, 64 equals 12 on 8 plus, we have to have a c value here, being 4. I've done that round the wrong way. Jeez. That's supposed to be 12. Okay. Is 64 on 8 plus 4. 64 divided by 8 is 8 plus 4 is 12, so that works. Okay, so we've done that right. I think this question got scrapped, so you might be able to scrap that one off. I think I'm using an old version of the test. But anyway, let's keep going. Order of magnitude of the number of visitors over a Saturday and a Sunday. So that's 4127 plus 5893. 417 plus 5893. It's 10,020. So to find order of magnitude, I just got to turn this into scientific notation, which means I'm taking a decimal point from here, going back 1, 2, 3, 4 spots. That's 1.002 times 10 to the power of 4. Therefore, the order of magnitude is 4. Alright, 10 to the power of 5.5 is closest to 10 to the power of 5.5, 316,227.76. So it's to round it to the nearest number. 227.7 gives me that one as the answer. Alright. You're missing a little bit of the decimal places there. Should scooch that over a smidge, but you get the idea anyway. Alright. Moving on. This one we have a graph. And the rule is... Oh, I just moved my camera slightly because I'm an idiot. Alright. Rule is y equals x squared over 2 plus 1. Okay. Again, I think this may be different in the version you guys did, but that's alright. Still the same premise to solve it. So all these are looking at y versus x squared, so I don't really have to treat it differently. I guess I'm just going to substitute these points in and see which one fits. And now, first thing I should note is that the point of origin should be, or the intercept should be 0, 1. So for example, this one here should be ruled out straight away because it's at 0, 0. Yeah. Okay, the rest of them will go through 0, 1, I think. So let's see what else there is. Well, that one doesn't seem to, but anyway. Alright. So I'm just going to chuck in the x value, square it for these bigger points and see which ones I can rule out. So 4 squared is 16, divided by 2 is 8. Well, these are already squared. I don't even need to do that then, because it's already squared, so it's just 4 plus... It's 4 divided by 2 plus 1. So it should be 3, so it's wrong. 4 divided by 2 gives me 2 plus 1 is 3, and that's wrong. 4 divided by 2, not 4, 16 divided by 2 is 8, plus 1 is 9. So that appears to be correct. That'd be 1 and 1 is 2. So yeah, it's definitely this one here. Okay. So what I was doing is substituting this value in here for x squared, dividing it by 2 and adding 1 to see if it equaled the second value, which is how the equation works, because it says y equals whatever x squared is divided by 2 plus 1. Okay. Alright, another thing, a table like this. We're going to find the values of k and c, which is fine. So what I'm going to do is I'm going to have to stop moving my camera for one. I'm going to find, I'm going to get this cord away from me. I'm going to have to find k and c. So let's add in an x squared row here and have a look at what that looks like, because it's dealing specifically with x squared. So it's 4, 9, 16, 25. Okay. So we're looking at these values here times k, which we're not sure about, plus c, which we're not sure about. Okay, so I think in this case we'll have to try and find the gradient k. We can do that using the 2-point method. So I can do 20, let's do smaller numbers. Maybe we'll do 4, 14 as 1 point, and 9 and 34 as the other point. We do 34, take 14, which is 20, divided by 9, take away 4, which is 5. 20 on 5 gives us 4. Okay, so the value of k is 4. And it has to be one of those two. And then to find the value of c, all I need to do is multiply x squared by 4 and find the difference to make y. So let's take this one here. 25 times 4 gives me 100. To get to 98, I would have to minus 2. So I believe C is the answer. Okay. Not too bad. Alright, length of string varies inversely as the frequency size per second. So this is one of those confusing ones that I'm just like, you just got to ignore the words essentially and pick things out. So length of the string L varies inversely. There's a little fish of 1 over f. Alright. So you could have that. I think we accepted that, or L equals K on F was also acceptable. So either or. Because you're just writing down that equation showing the relationship. So they're both fine. Okay. So if the 20 centimeter long string vibrates at a frequency of 650, write an equation. So 20 is equal to K over 650. Alright. So if I'm writing an equation, I basically just want this form down here with K filled in. So in this case, multiply both sides by 650. And they give you the value of K is 13,000. Yeah. Which means L is equal to 13,000 on F. Alright. So there's 2 marks there, one for finding K, one for writing your equation properly. Find the length of the string that vibrates at 800 cycles per second. Okay. well, that would be L would equal 13,000 divided by 800 cycles per second. .25 centimeters. Find the number of vibrations per second. Correct the decimal place of a string that is 12 centimeters. So this is use the same rule, but have the L and find the F. So 12 is equal to 13,000 over F this time. And you can do a bit of mucking around, but you should know that when you're dealing with an unknown on the bottom and an answer here, you can basically swap these two. Essentially you multiply, so you divide both sides by 12, multiply both sides by F, and it swaps their places. So F equals 13,000 over 12 is an acceptable thing to do. Okay. Right, 13,000 divided by 12, which means that it vibrates at 1083.33 cycles per second. Yeah. Alright. Easy. Let's keep going. Okay, so we're looking at a variation of y is equal to kx squared. And we're going to find out the k, which will help us fill in this table as well, because we can't be exactly too sure. It's a tricky one because this is missing a pattern. It would be very easy to assume that this is 16, 32, 64, 128. We can't exactly be sure, so that's also interesting that it asks to find k before completing the table, which seems to suggest that it's not as easy as it seems. So let's do that. So let's fill in x squared. (16, 36, 64). Okay. And we go take 2 points from here. So we'll take so y being 32 and x squared being 16, which is a nice and easy one. So divide both sides by 16, which gives me k equals 2. Which means I'm just multiplying both of these numbers by 2 to find their y values. So even though that may have seemed like it was the pattern, it's deceptive. Alright, complete the table, sketch the graph of y against x. Notice it's x, not x squared. So we're not using that new row, we're using the old row. So x is 2 and 8, which is about there. It is 4 and 32. It's 6 and 72. It is 8 and 128. It seems to suggest a pattern. Going upwards like that. Okay. That's x and that's y. So I'd say that you'd probably have a point. I don't know the rule, so I can't write the rule. A point for the graph and a point for labeling the axes is what the 2 marks are for. Alright, John's weekly wage, W, varies directly with the number of hours he works, H, per week. So he earns, that means W equals KH. He earns $318 and he works 24 hours. which means that his hourly salary is 318 divided by 24. $13.25. Okay. How much does he make for 40 hours of work? Means I multiply this value by 40. I get 530. Let's say 1 mark for that, 1 mark for K. And then the bakery sells 450 cupcakes per week. What's the order of magnitude if the total number of cupcakes is sold over 8 weeks? So this is an easy question. Multiply that by 8. It's 3,600. To find the order of magnitude of that, we turn it into scientific notation, which is 3.6 times 10 to the power of 3, which means that's an order of magnitude of 3. Nice and easy. Just remember, order of magnitude and log are not necessarily the same thing. It can be, but it doesn't always have to be. Alright. We're doing transformation here, so this is just 1 over x, which is 1. It's a half, a fifth, 1/10, 1/20. Sketch the graph of y against 1 on x. So it's y, it's 1 on x. And this graph always trips people out a little bit because your first value being 1 and 40, you're used to plotting left to right, but when it's an inverse graph, 1 and 40 is up here. You start plotting right to left, which really messes with people. But alright, a half's a 0.5. Oh no, am I doing that? Yeah, 0.5 and 27.5. So it's probably like there ish. A fifth is 0.2. The y is 20. So you can see a straight line is sort of appearing there. Any like bit that's off is just human error. 1/10 is 17.5, which is what are these? 1, 2, 3, 4. So they're probably 0.2. So a smidgy bit less, maybe about there. All right, got that one. Might make that point a bit more defined. And then lastly, we have 1/20 and 16.25, which is here, and that's 17.5, which means, what would this be, 10, 12, 14, 16, 18. That dot should be marginally higher, and this one should be like there. Anyway, it's not a great, I'm not a great sketcher, but it should turn out pretty straight. Alright, so draw a nice straight line through them. Yeah. Yeah, it says sketch the graph of 1 over x and determine whether this transformation linearizes the value. I'll say yes, it does. Linearize. Alright, because there are 3 marks here, 1 for the axes, 1 for the sketch, 1 for that answer. Find the rule that relates to, oh God's sake. Alright, find the rule that relates to x and y. I gotta get better at not knocking this camera. Alright. So we have y. Does it say that it directly relates? It doesn't necessarily say that, so we can't assume. So y equals k on x with a potential plus c. Well, it should be a plus c because our 0 is way too high. So that makes sense. It looks like the c comes in about 15, but I can't really judge that. So let's just fill in what we've got. All right, let's go. We've got 1 and 40, which is probably a nice one. So 40 equals k on 1 plus c. So I'll use that to solve eventually. And I've got to use 2 points on here to find k, which is essentially our gradient. So let's do... We'll use those points. So we use 1 and 40. And we'll use... How about 0.2 and 20? Something like that. All right. So y2 take y1 gives me negative 20 divided by x2 take away x1 gives me negative 0.8. If I were to, firstly let's just make that positive. 20 divided by 0.8. Divided by 0.8 is 25. That doesn't seem right. Oh, that's the yeah, no, that's fine. That's the gradient. I thought it was the line set for a second. 25. Okay. Which means that we can fill this in now. So 40 equals 25 divided by 1 is just 40 plus c, which means my c is equal to 15 as well. So it should be y equals 1 on x, 25 on x, plus 40, I believe. We got that right. Got a bad feeling that I've got that one wrong. Just give me a second. I did because I used the wrong value here. Damn it. Did I? Oh no, no, that's right. Well, 15 seems to work. Oh, why have it done plus 40? It's plus 15. That could be part of it. Yeah, okay, that makes way more sense. I was looking at some of the values and I was like, I'm not too sure about this, but that seems to work out much better. You know, if I'm looking at something like 25 divided by 2 is like 12.5 plus 15 is 27.5, so that works out. I was getting all these numbers in the 40s and I couldn't figure out why. That's because I'd plus 15 and 25 together for some dumb reason. Alright, anyway, so that should be your equation. That's good. Just goes to show everybody can make mistakes. Alright, what are we looking at now? So we're looking at the body mass of birds, so we're just doing logs. I hope this one can do log. Oh, I don't think that's any of the values. I think the first one is log 20, which it is, which is 1.30, rounding to 2 decimal places. Alright. Next one is 300 log 2.48. crow is 341. 2.53. Buzzard is 658. Log 2.82. Rounding up. 1100. Log 3.04. Very nice. 2000. 3.3. 30. Goose 2300. 3.36. Turkey is 8750, which has a log of 3.94. Lastly, ostrich is 71000, which has a log of 4.85. Alright. Cool. Easy. Now, remember, if you're doing that on your CAS, it's a little bit differently because you have to type in like log 10. But it should work the same way. Other than that, you just put in log 10 of X. Log 10 of whatever your value is. Anyway, so using the log values, which are these ones here, how many times heavier is a turkey compared to a pigeon? So if that's 3.94 for the turkey minus the weight of a pigeon, which is 2.48, right? That will give you a difference of 1.46, which means the difference between them is 10 to the power of 1.46. Gives you 28.84, which rounded to the nearest 10 is 30. 30 times heavier. Alright, so I'm assuming 1 mark is for solving the difference here and 1 mark, or it might be 1 for this and 1 for rounding. Okay, and this is the last question, and then we're done. So if T-Rex had a log mass of 6.85, what's the actual mass? Okay, so remember, if we're doing log of X is equal to 6.85, we're actually saying 10 to the power of 6.85 is equal to X. Okay, so 10 to the power of 6.85 gives me that value there. Oh goodness, it's to the nearest decimal place. Okay, 7079,457.84 grams. It's pretty big. And that's it. One thing that was asked of me a while ago that I might quickly mention is somebody asked me why when we solve this number here and find that this is 28.84, why is it that the turkey divided by the pigeon does not give you that value? Alright, so if you did the turkey being 8,750 divided by 300, is it for the pigeon? It says 29, not 28.84. The reason is because when we do our logs, we rounded them to the nearest decimal place. If we let them be, it would be 28.84, okay? But that's what the question tells you to do, So it says to round them to 2 decimal places and then use that rounded answer. So that's the important part there. Anyway, that's it from me. Hopefully you've learnt something useful. Good luck with the test tomorrow or Thursday or whenever you're doing it. Yeah, thanks everyone. Bye.